Hi everyone, this video we're going to just go through the answers to the homework. So let's look at page 7, so 7 through to 12 on the homework. So check it out. Let's look at Eric's answer firstly to the one on page 7 on Class Kick. I like the setup, guys. Check out the U and the V and the way he set that up. I think that's a great way to set that up. So he's done that correctly. He's correctly applied the formula. Looking good. I know Eric's feeling chuffed right now. And substituted in what we want to know. We wanted to know the slope at the point 1/4. So it didn't matter about the y value there. All we needed to know is that the x value is 1. So we've got the derivative there, 1/3x plus 1 squared. We substitute in x equals 1 and we get 1/16. So that's the correct answer to the one on page 7. Let's look at page 8. And I'm just going to go to someone else's here, Nicole's. A little bit trickier with the derivative because of the 2x plus 1 to the power of a half on the bottom here. Most of you are working on this one in class. So Nicole's correctly done the derivative of u and v there. Then she has done that tricky bit there where we're going to make root 2x plus 1 the common denominator on the top line. She's done that correctly, then multiplied the two together, and she's got this line right here, which is correct. That's not easy. So if you can get to there, you're doing well. So after that, we want to know what's going on at x equals 12. So substitute in 12 into that formula and simplify gives us 2/25 for the answer. So the slope of the curve there when x equals 12 is 2/25. Just want to show you now the answer to this is question 9. G of x is 2x minus 1 over 1 minus x squared. So we want to know what's going on there. This equation of the normal, I think it was. Equation of the normal to that curve at the point 2 minus 1. So first we need the derivative. Here it is here. Check it out using the quotient rule. U is 2x minus 1. V is 1 minus x squared. So we've got u dash v minus v dash u over v squared. Simplifying the top line gives us 2x squared minus 2x plus 2. That's as simple as we need it. We want to know what's this equation of the normal here. So let's first work out what the slope of the curve is at 2. So I substitute 2 in there. That gives me 2/3. Therefore, the slope of the normal must be negative 3/2, the negative reciprocal. Easy. Then we work out what the equation is. Well, we've got the gradient. We've got a point on the curve. That's 2, -1. So we substitute it into the formula for the equation of a line, giving us c equals 2. And the answer to that one is negative 3/2x plus 2 for the one on page 9. Page 10. First says, what's the gradient of the curve at the point where it crosses the x-axis? Okay, so again, using the quotient rule, we work out the derivative. But first, what's the point where it crosses the x-axis? That's where y equals 0. So it's when this is equal to 0. And as we've been talking about, a fraction is equal to 0 when the numerator is 0. So that's x equals 1/2. So I've applied the quotient rule here, guys, and that gives me this, 5/x plus 2 squared for the derivative. Then I just simply substitute in 1/2 in for x, and that will tell me what the slope is at that exact point. So here we go, at x equals 1/2, the derivative is 4/5 or 0.8. Excellent. Second question, does the curve have a stationary value? Well, you can see from the derivative, the top line is never equal to 0. This thing, in fact, is never equal to 0, so there's no stationary value. Here's what the graph looks like. You can see -2, we've got the asymptote there, and you can see there's no stationary values. There's no values of x where this slope of this curve is equal to 0. That's page 10. Page 11, the area of the triangle. A little bit of work involved in this one, as I'm sure you discovered. So let's go to the answer. Here's what the sketch looks like. If you draw the tangent in pink there and the normal in blue, we're looking for the area of this triangle. Of course, you've got the graphing program. It's nice and easy. You can see what the base is. You can see what the height is. So that makes life easy. The height is 2, so we just really need to work out what the x-intercepts of these two lines are. So we need the chain rule and the product rule in this case to work out the derivative. Just check and see if you got the right answer there. I've got the working there. If you want to pause and have a look at my working, that's what you should have for the derivative. Substitute in negative 1s tells me that the slope is 2, therefore the slope of the normal is negative 1/2. I can use those two facts to work out the equations, and then I can do something like, well, if the equation of the tangent is y equals 2x plus 4, what's the x-intercept of that line? So that is when y is 0, which gives me x is negative 2. Same for this one here for the normal. Put y equals 0 in there and solve, and that gives me the x-intercepts. So if I go back to the graph, you can see the normal going through 3 in this case, the tangent going through negative 2. So the area, a half base times height. Give yourself a pat on the back if you've got a half 5 divided by 2. Sorry, a half times 5 times 2, which is 5. Here's the last question. So using the quotient rule gives me this here for the quotient rule. You can see I've factorised the top line, not necessary, but you could have left it in that form there and that would be fine for dy dx. Done. Find the coordinates of the stationary points on the curve. The coordinates of the stationary points is when the top line is equal to 0. So when I factorise this, that gives me 1 and negative 3. Of course, we don't just want the x values, we want the y values as well. So when I substitute 1 and negative 3 back into the original equation, I get 1 and negative 7. So there's the 2 points, negative 3, negative 7, or 1, 1. Hope you went well with that homework and that all of the stuff that we've done makes sense. I'll be back on Monday to check out and see how you're going. So good luck with all the work that you have to do today and tomorrow.